All right, so in this segment, we are going to be covering atoms and subatomic particles. So I'll give you some definitions of atoms just in general. And we've kind of already covered them when we were talking about an element. Okay? So they're the smallest part of the element that retains the chemical characteristics of the element itself. Okay, so that's a mouthful. They're the smallest part of the element that retains the chemical characteristics of the element. Okay. All matter is made up of atoms. Okay, and that's sort of a review from last class. Atoms are made up of 3 different subatomic particles. So atoms are made up of 3 different subatomic particles. Okay, and the number of each subatomic particle determines the chemical characteristics. So this would be the number of each subatomic particle. I keep wanting to write substance. Determines the chemical characteristics. Okay, so this little bit about chemical characteristics, that's going to be another common theme. Chemists are generally concerned with reactivity. If I mix 2 substances together, will they react? What is the reaction going to produce? Is it going to react in a timely fashion? Is it going to react explosively? We want to know these things. So a lot of what we are going to be covering is we need to know this information in order to predict reactivity, because that's sort of one of the main end goals. So whenever we're talking about chemical characteristics, the chemical characteristics, okay, those are going to describe the reactivity of the substance. Okay, the reactivity of the substance is then related to the number of these 3 subatomic particles. So the goals for this section would be that you need to identify the subatomic particles by charge, by their location, and by their approximate mass. And if I give you the symbol, the name, or the atomic number, so any of the 3 identifiers from the periodic table, you need to be able to determine whether that's an element, an ion, an isotope, and determine the number of each subatomic particle. Okay, and that's what we're going to cover next. So when I keep talking about these 3 subatomic particles, you guys know them as, shout them out, protons, neutrons, and electrons are the 3 subatomic particles. I left myself too much room here. There we go. Okay. So we need to identify them by location, by charge, and by mass. So the charge on a proton is?
Positive.
It's positive. Okay, so we'll write that down as protons are positive. So they essentially have a positive +1 charge. Neutrons, charge, none, because they're neutral. So we have 0 charge. Electrons, they're -1 because they carry a -1 charge. So neutrons are negative, and they have a -1 charge. So just based on the name, that information is mostly intuitive. Okay, the location, okay, based on well, we're going to go with the simplified model of the atom. Okay, the location of a proton is being in the nucleus. Okay, so it is located in the nucleus. Neutrons are also located in the nucleus. And electrons are located in the area around the nucleus. So you can kind of think of it as an electron cloud. So they exist in the space around the nucleus. So we're going to call it a cloud around the nucleus. Okay, so your very simplified version of an atom would be that you have protons and neutrons, and those make up the nucleus of the atom. And then you'd have electrons, which are usually written as lowercase e with a little negative superscript. So I have a bad habit of writing in my scientific shorthand. So if you ever see an e with a negative superscript in the notes, I'm talking about electrons. Okay, a lot of textbooks do that too. It might also be written like that. Okay, so you've got nucleus, and then you have these electrons in a cloud surrounding the nucleus. Okay, so there's your charge and your location. We also have to be able to identify them based on approximate mass. Okay, now we're not actually going to give you the mass in grams of these. It's far too small to be useful. We're going to give it an approximate mass of 1 or 0 units. Okay, so protons have an approximate mass of 1 unit. So this would be 1 unit of mass. Okay, just an arbitrary unit, doesn't matter what it is. The neutrons have an arbitrary mass unit of 1 as well. So 1 unit of mass. And the electrons, for our purposes, have 0 mass. They do in fact have mass, but this is another case where it's so small that it's negligible. So the electrons have 0 mass units. So when we were looking at the periodic table, and I had highlighted that for boron it was at 10.811 as being the atomic mass of boron, the mass of that atom is made up of the protons and the neutrons. The electrons don't add anything really to the overall mass of an atom. So there's your protons, neutrons, electrons. You do need to be able to identify the charge, the location, and the approximate mass of each as either 1 or 0. Okay. That's not quite enough. We need to be able to determine the number of each subatomic particle in an atom. Okay. So how do we do that? Okay. We're going to start with protons. Okay, how do we determine the number of protons in an atom? It turns out the number of protons is equal to the atomic number. So the number of protons is equal to the atomic number from the periodic table. Always. So I had said that boron had an atomic number of 5, and that nothing else had an atomic number of 5. That means that boron has 5 protons. Any element with 5 protons, any atom that has 5 protons is boron. That's the identifier for boron. Okay? The number of protons of an atom never changes. Okay? So the number of protons, so for an element, I'm mixing up element and atom here. The number of protons for an element will never change. So that's protons. So that you can read directly off the periodic table. So the number of protons for carbon is 6. The number of protons for hydrogen is 1. That you get directly off the periodic table. There's no calculations involved. If we were to do electrons, okay, for electrons now we have two different scenarios. We can have an uncharged species, which would be as written from the periodic table. So these are called uncharged species. So that would be something like sodium on its own. Okay. We also have charged species. Okay. I'm using the word species to denote an atom or an element or any substance in its state. Okay? So an uncharged sodium atom would be just sodium written as the atomic symbol from the periodic table. The charged sodium atom would be sodium, and there would be a little superscript as a positive charge. Okay? If you have an atomic symbol and a superscript with either a positive or a negative number, okay, it could be 1 in this case, or it could be 2. So you could have oxygen on its own, or you can have oxygen with a little 2 negative. That's a 2. Okay, so you have the uncharged species and you have a charged species. A charge can either be positive or negative. The charge is changing the number of electrons that element has. So we're changing the number of the subatomic particle of the electron, okay? Because the electron carries a negative charge. Okay, we're not changing the mass, because the mass for our purposes is 0 mass, but we're changing the charge on that atom. Okay, so for uncharged species, okay, so for the uncharged species, the number of protons is equal to the number of electrons. Because if I have 5 for boron, if I have 5 protons, that would be 5 positive charges. I would need 5 negative charges to balance that out so that it was overall a charge of 0. So 5 positive, 5 negative. So for an uncharged species, the number of electrons is equal to the number of protons. That's how you calculate the number of electrons for an uncharged species. For a charged species, okay, what we are going to go with is, we'll draw this down here. The number of electrons is equal to the number of protons. Okay, but here we would need to add or subtract, depending on whether it's positive or negatively charged, the charge. Okay, we'll go through some examples once I've got all the definitions down. Okay, so we've gone over protons, we've gone over neutrons, electrons. Next one up is neutrons. Okay, so neutrons located in the nucleus, they have 0 charge, but they have 1 unit of mass. Okay, so charged, uncharged doesn't matter because they don't affect the charge of an atom. What they do affect is the mass of an atom. Okay, so for neutrons, I want to make sure I write this down properly for my notes here. The number of neutrons is equal to the atomic mass from the periodic table okay, so it's the atomic mass from the periodic table, I'm going to put that in brackets, minus the atomic number. Okay, so you take the mass from the periodic table and you subtract the atomic number, which is essentially subtracting the number of protons. Because the mass, okay, for boron, for example, okay, so for boron, if the mass is 10.811, we round that up to the nearest whole number, because you can't have a fraction of a subatomic particle. It's either there or it's not. So we would take this 10.811 and we would round that up to 11. Okay, so you guys, are you comfortable with rounding? Anything higher than 5 you round up, anything lower than 5 you round down. So you would take that as 11 as the atomic mass, and you would subtract 5 as the atomic number. So you'd take 11, that just looks like a hot mess now. So that's the number of 11 in parentheses, and you would subtract 5, which is the atomic number. So for boron, you would have 6 neutrons. Okay. So the number of protons and neutrons are not necessarily going to be the same. Okay. Sometimes they will, and that's just serendipity. That's just how it worked out. But they are not always going to be the same. Okay. So let's go through some examples. So this is most definitely testable material. So I do need to be able to give you an element, and I'll ask you to calculate the number of subatomic particles for that element. So if I give you aluminum, okay, you'd have to first off locate aluminum on the periodic table. Okay, and if I said, how many protons does aluminum have? So you look at aluminum on the periodic table, you look in the top left-hand corner, it is group 13, period 2, 3. And it has 13 as its atomic number, so it has 13 protons. Okay, just straight off the periodic table. So this is 13 because 13 is the atomic number. So if I asked you for how many electrons was in an uncharged aluminum atom, because if I'm just giving you straight up aluminum and I'm not indicating if it's charged one way or the other, assume it's uncharged. How many electrons does it have? 13. It has 13 electrons because the number of electrons is equal to the number of protons. So if I ask you how many neutrons it has, okay, you would go to the periodic table, you would locate aluminum, you would round up the atomic mass to the next nearest whole unit. So it's 26.9, so you'd consider it 27. So you'd write 27, you subtract the number of protons, so you'd subtract 13, and you would get, and my mental math is going to fail me miserably, 14 neutrons. Okay. Here, I get, so on the assignment you're going to have to do these, and on the term test you'll have to do these. I get people making mistakes here. I know that part of it is just a mental math error. So I know that you guys can take 27 and subtract 13, no problem. Just the way that calculators and our dependence on computers have gone, I would say double check that number using a calculator, because sometimes the subtractions get a little weird. Okay? So either add it back up in your head or do something to double check your math there. Because I think that people know how to do this calculation, and it's just a mathematical error, and that's why they get it wrong. Okay, so either write down your work, so write it down as I've written it down here, as atomic mass subtract atomic number equals, and then I can give you a part mark if it was just a mathematical error. But if you just write down 15, I don't know whether it's because you didn't know how to do it or it's because it was just a mental math error. Okay, so even though we haven't started any mathematical stuff for this next first term test coming up, I would say make sure you use a calculator while you're doing these things. Okay? There's a mathematical saying, it's I can integrate and derive like the wind, but I can't add or subtract. Okay, it's just one of those things. We've become too dependent on computers. So that's aluminum. Number of protons, number of electrons, number of neutrons. Okay, we'll do one more. So we'll take something like cobalt. Okay. Actually, is aluminum a metal or a non-metal? Metal. Okay. A, because it's on the left side of your staircase, and because intuitively you would recognize aluminum as a metal. Okay. So cobalt now is going to be located as a transition metal. It's going to be in that rectangle in the center of your periodic table. It is group 9, period 4. Okay, so it's the coordinates for cobalt. It has the atomic symbol uppercase C, lowercase o. So that one makes sense. So if I say, how many protons in a cobalt atom? 27. And that is because the atomic number is 27. For those of you following just the video lecture, I would still recommend going through the exercise as I talk instead of just listening, just to double check to see if you're getting the right answer, same as the classroom. So you can shout out the answer to your computer. Nobody will hear you, but at least you'll know that you got it right or wrong. Okay, so number of protons is 27. Number of electrons for an uncharged cobalt atom? 27. If it's uncharged, the number of protons is going to equal the number of electrons because the positive and negative charges have to balance out. The number of neutrons? Okay, you would look at the atomic mass for cobalt on the periodic table is 58.9, so you would round that up to 59. So you'd go, the atomic mass is 59, you'd subtract 27, and you end up with 32 neutrons. Okay. So you need to be able to determine the number of each subatomic particle for all of the elements on the periodic table. And in the next segment, we are going to go over more of the charged, uncharged species. We're going to talk about ions, and we're also going to talk about isotopes, which is going to be changing the number of neutrons.